Welcome to a video tutorial on map elements. In this video, we'll learn about working with the pieces to complete a whole and informative map. First, let's talk about the individual pieces of the map that are required. We have the figure heading. This replaces the title in publications, and this is where we'll describe what the viewer sees on the map. The north arrow, providing the reader for a reference for north and possibly other directions. The scale bar, for estimating distance on given maps. Landmarks are specific locations of interest to key the reader into specific places on the map or to key them into specific places discussed in the narrative. Legends, which identify all of the individual characters on the map. And the overall aesthetics, where you as the map maker get to become the artist and produce a map that is aesthetically pleasing while capturing the elements above. So let's look at a map from a publication that I published in 2017 in the American Journal of Tropical Medicine and Hygiene, given here for the full reference if you're interested. And let's look at those individual components that we spoke about a moment ago. First, we have our figure heading, which describes the details and keys the reader in to what to look for on the map and how it relates back to the narrative. Oftentimes in publications, our goal as an author is to get the reader to understand the paper from reading the abstract and looking over the first couple of figures. So the figure heading should be detailed enough to key the reader in if they hadn't read the entire paper, though there will be details in the figure that will require the reader to read the narrative. If we look at this map, we have each of those elements that we saw earlier. First, we can see that each of the pieces from our last slide are present here. We have a north arrow. We have individual landmarks, such as Issyk-Kul Lake, individual city locations, the names of surrounding countries. We have our scale bar giving us a distance for the map, and we have our legend indicating each of the individual pieces of information that the reader needs. We also have in this map an inset map. That's this small map here in the corner, illustrating the location of Kyrgyzstan in red and its place in the global context, or at least in the Eastern Hemisphere context. And then we can see we've zoomed into Kyrgyzstan, and now reading the legend, we can see the background of Kyrgyzstan. In this case, I've chosen to use elevation and presented it with some detail. That's also color ramped here from dark to light. The darker the gray, the lower the elevation. The lighter the gray, closer to white, the higher the elevation. And I have some other information on the map for the reader as well. In this case, this is a study on ecological modeling, and what we needed to know which data were used for training the model, here indicated in yellow, and for independently testing the model, here indicated in green. Those landmarks will occur in other maps within this same study, which we'll see later in this presentation, and I've indicated those by a red star with dark, bold, black text for those city names. So you can see that each of the components, each of our elements, are present on this map, and I've used bright colors like green and yellow to immediately clue the reader's eye into the most important information on this map, which for this particular study was the location of anthrax outbreaks used to perform the spatial analysis for this particular study. Now let's look at a map from another study that I co-authored with Ian Krachalik, a previous spatial epidemiologist and PhD student in my lab. And here we have a study from emerging infectious diseases looking at the distribution of human anthrax cases in the country of Georgia. And we have several pieces of information on this map. Now, notice the same points of reference are available on this map that we discussed in the last map. we have a north arrow, we have points of interest, we have a scale bar, we have a legend, we have a figure heading, each providing the reader with pieces of information to interpret this map. Now in the last map, we had the base map or background of Kyrgyzstan was simply illustrated by a grayscale color ramp. In this case, our background is political boundaries, and we can see that those political boundaries are color-coded from light or white for 0 to darker colors for an increasing number of events, in this case, the number of livestock that died from anthrax. So we've got a color ramp, or what we also describe as a choropleth, here increasing values. Choropleth means that the values are not categorical, but rather increasing in value from one color to the next. So we can learn something from this map about livestock anthrax. And then here in red, we have what we call graduated symbols. Notice that all my dots are red. Increasing in size also corresponds to increasing in value of incidence. In this case, the larger the circle, the greater the amount of human anthrax cases per that community for the time period for the study. So you can very quickly look at the map and see that here we have some areas with very high incidence, also here, and in contrast we have areas here with very low incidence. So the graduated symbols are important for helping us look at individual places and knowing very quickly whether they have a large or small quantity of some phenomenon. So here we're looking at choropleth with the background and graduated symbols, each indicating increasing value, the colors in the polygons, and the increasing size in the points. If we return to our study in Kyrgyzstan, here we can see a few features are still present. We have our figure heading. This describes detail that's important for the reader about the map. But now you'll see some of the detail from the previous map is missing. I've no longer drawn the reader's attention to a north arrow, which was here, or a scale bar, which was here, because the readers have been keyed into that in a previous map. I've also removed the background elements from the first map in Kyrgyzstan, which were those elements describing Kyrgyzstan's position relative to Kazakhstan, China, and Uzbekistan. However, in this map, I really want the reader to focus on these graduated colors here, where I have a continuous color ramp from green to red. The greater the intensity of the red, the greater the likelihood of the occurrence of anthrax, is what this map is telling us. So I want the reader to very quickly see the map and find these areas in red and have points of reference, such as Osh, Talas, compared to Narun, where they can make quick comparisons. Narun has no areas predicted by whatever this model is, whereas Osh, Talash, Bishkek, Karakol each have areas in red. So in this case, I've made decisions consciously to leave map elements out because I want to draw the reader's attention to lesser information that's more important. That's why this map has fewer elements than previous maps. But keep in mind, this map was published in tandem with the first map of Kyrgyzstan, so all of that other contextual information the reader can pick up from having seen both of these maps in the same paper. So as a map author or a map creator, you will have to make decisions about which pieces of the elements to keep and which to leave out. Notice in this case, the north arrow is less important and the scale bar is less important because I really want the reader to focus on where GARP was predicting and compare that to areas where it was not. In this particular study, elevation was also important because you'll notice these flatter areas on the edges of these really rough parts here in gray indicate that in the flat areas or less mountainous areas of Kyrgyzstan is where we most likely predict anthrax. So in this case, notice that rather than just having the light grayscale that I showed in the first map, I've now turned that into a shaded relief map so that it looks like it has almost a three-dimensional feel to it. So again, that's an aesthetic choice made to again draw the attentions of the readers to the areas in red and the areas that are relatively low-lying on the edges of the ranges. Now we'll turn our attention to a paper published by Jake Hightower and Ian Krachalik with Dr. Glass and myself, two faculty members, and Jake and Ian were both graduate students here at UF. And here we were mapping the historical distribution of Francisella tularensis. It's a pathogen that causes the disease tularemia. And in this set of maps, we can talk about a couple of things. First, all of those elements are present. We have our north arrow, we have our scale bar, we have the country of Ukraine, and we have individual oblasts, which is the province or state equivalent in Ukraine, identified on the map. And we have individual points reflecting where Francisella tularensis was isolated. And we have this point map, a color ramp from green to red. The closer we get to red, the more recent the event. The closer we get to green, the older the event. I use this as an example to contrast what I showed you earlier in Georgia. In Georgia, we used graduated symbols because each symbol indicated a different quantity of anthrax per population or higher incidence. In our Ukraine situation, we're not saying there was a greater or lesser quantity at any given location, but rather those individual events happened at different times. So in this case, we've used a color ramp for time on these individual point locations in Ukraine, and we've used graduated symbols for increasing quantity or higher or lower quantities at different locations. If you want to display quantity, you should display graduated. If you're just interested in illustrating a difference, such as a difference in time, you can use different colors. And if you want to illustrate differences, for example here, the source of isolation, whether it came from an arthropod like a flea or a tick, or a mammal like a rabbit or a rodent, then you can indicate different colors. In this later case, where we have categorical coloring, we don't need continuous color. So we can graduate for quantity, we can color ramp for time or sequence, and for categorical, we don't need any continuous color. Each individual color can represent something totally unrelated to something else. And remember that we can have a color ramp also for quantity in our polygons, which is indicated here in our Georgia example as well. As another example, we can start to take those map elements and start to learn lots of information about analyses that were performed in the study. So in this case, I'm not going to teach you how to perform each of those statistics, but rather show you how the map elements are brought together here to illustrate the information performed in an analysis. At a later date in class, we'll talk about how to perform these analyses, but for now, let's focus on the map development. So let's take a look at just this top map of the two, again from the Hightower paper. And let's take a look at the individual elements here. We have the country of Ukraine, and we have the individual provinces, so we can locate our position on the map. We have scale bar, we have a north arrow, we have a map legend, we have something categorical here, just these light blue or light gray areas indicating historically defined information. And we have information from our spatial analysis captured as points of interest on the map in the form of text, and captured in these color-coded clusters defined by a circle and points that are associated with that color. Now that information would come from the statistical analysis itself, something called a space-time analysis. And we'll talk about how to do that at some other date in class. What's important here is how we define that cluster for the reader. The reader can very quickly see there was a cluster here in red, and it had associated red points. There was a cluster in purple with associated points, and so on. We can also see how long that cluster lasted. In this case, 2 years, 1990 and 1991. In this case, 7 years, 2001 through 2008, and so on. So we can learn something about how long that cluster persisted, where that cluster existed, and which individual members were a part of that cluster. We can also see in parentheses here what the radius of this circle is. Now again, you'd have to understand the statistic and or read the paper to gain that information, but that's all identified here on the map for us. So all of those map elements can be pulled together to help describe some complicated spatial or spatiotemporal statistic and give the reader a very clear and concise understanding. Likewise, there's another way to perform spatial clustering inside of SAT-SCAN, something called a multinomial cluster. And now what you can see happening is our legend becomes very important, not just for indicating what individual colors mean, but also information about the statistic that was performed. So here, the information about the time period is directly associated with the individual color. So this time, the blue cluster persisted from 1962 to 1977. We can see that's over here. The yellow cluster persisted from 1971 to 2000, and that includes a much larger number of individual points. We still have points not included in our cluster, just as we saw in the map above. We still have our north arrow. We still have our scale bar. So we still have individual map elements, but in each case, different parts of the map are playing a different role in providing the reader information. In this case, you'd have to have each the map, the legend, and the figure heading to understand what each of those pieces of information in the legend mean. In this case, I'll give just a single example, and that is that any of the areas identified in yellow on the map, or here in the legend, there's a much higher relative risk of getting tularemia or Francisella tularensis being isolated from water or farm produce. Whereas in the case of the blue dots, which occurred down in the southeast there a moment ago, had a much higher likelihood of being recovered from number 2 arthropods. So in this case, I'm taking advantage of the map, the figure heading, and the legend to gather the information I need as a reader to understand what this map is trying to tell us about the likelihood of isolating that bacteria from those historical sources. So, in summary, we have several key pieces that are required to make a map or in the case of Kyrgyzstan, a set of maps work to convey the appropriate information to the reader at the appropriate time in reading the paper. The figure heading is going to provide key information on the map purpose, and this will also replace map titles and publications. If you're writing a manuscript or a laboratory assignment for this class, no titles, use figure headings. Don't use both. Traditionally in introductory map making classes, students are taught to make titles, and that is important for understanding what the map tells you about, but oftentimes those titles are used when maps are standalone and not provided with a figure heading. In publications and scientific documents, figure headings supersede the need for titles. North arrows are important for keying the reader in on which way to look for north. This is important for keying the reader in on a key cardinal direction. You may choose, for instance, maps of Antarctica. It may be south is more useful than north. Those would be decisions that you have to make, but you've got to key the reader in on which way to look for up. Scale bars are critical for providing scale for converting from map units to spatial distances, or how big is it on the paper compared to how big as it is in real life. For example, so many centimeters on the page translates to so many kilometers on the ground, and use the metric system. Don't use the English system, particularly in class or in scientific publications. Landmarks are specific locations of interest. These are to try and get the reader to take their eye directly to where you want them to look. Sometimes you want these to be distinct, and sometimes you want these to be fairly subtle. Look back to the Kyrgyz example, where we show large city names for Kyrgyz locations and small country names for neighboring countries, because we want the reader focused on Kyrgyzstan, but we want them to have the context of where Kyrgyzstan is relative to neighboring countries. So try and relate the landmarks or specific locations of interest back to information in the figure heading and in the text of the manuscript. Remember, these maps are part of a larger document, or maps are a body of figures that go in a narrative to help tell the story that you're trying to tell with your scientific narrative. Legends provide key information on color, size, and shape choices. In this example, we had cities as stars or asterisks, and we had green and yellow dots for independent testing and model building in the Kyrgyz example in the first slide. We had graduated symbols in Georgia from small to large circles. We had color ramped years in Ukraine, and then we had categorical points of source of isolation from mammals, fleas, water, etc. All of that information was captured in the legends, and much of that information was augmented by information in the accompanying figure headings. And finally, we have the aesthetics of maps. You're going to have to make trade-offs between map visual quality and key information on the map. The goal is to try not to distract the reader away from what you're interested in showing them for something else in the map. For example, in the Kyrgyz maps, where I showed each the predicted distribution from the niche model, the green to red color ramp, the second Kyrgyz map, or that first map, the grayscale background of elevation was a relatively neutral and mild display on those maps, so the reader would key in on the red areas for the predicted model, or they'd key in on the yellow and green dots. So I had to make aesthetic trade-offs between what I wanted the reader to see and what I thought made an attractive map. From the first to the second map in Kyrgyzstan, throughout the course of that paper, I described that the mountain ranges are important barriers possibly for anthrax, and so we illustrated those with the shaded relief map. So those were some trade-offs that were made to try and make an aesthetic map, but without distracting the reader. Had I made that shaded relief in a darker color, in a brown color ramp or a reddish color ramp, or a dark green color amp, other colors that we often see used for hillshades like that. If we had used those color choices, we would have distracted from the information about the GARP model, and that was the key element for that map. So you've got to make trade-offs between what you think is an aesthetic map and what's an informative map. And informative should always win out over fancy aesthetics. So hopefully this will get you started at making useful maps for the class and making useful maps as you go forward. Good luck.